All right, so next let's actually take a look at the Mongo shell itself and see what's in that database and mess around with it directly. So at this point, we're not going to be using Spark, we're just going to be using MongoDB itself. And to get into the MongoDB shell from your MongoDB primary server, you just type in Mongo, and that gives you a shell prompt from which you can execute any arbitrary JavaScript. So first thing we need to do is say use movie lens to get into the movie lens database that we wrote our stuff into. And from there, we can do queries, like, for example, db.users.find, parenthesis bracket, curly bracket, user underscore ID colon 100, curly bracket, and parentheses. So you can see we have this very JavaScripty syntax where the find function takes in this expression that we want to match on. So what we're going to do here is bring back a collection of any documents that match this expression where the user ID equals 100. So this should give us back any document that has a user ID of 100. And sure enough, there it is. So it turns out user ID 100 is a 36-year-old executive in the zip code 90254. I think that's California. Let's have some more fun. So one thing you might have noticed is that we're not actually, we never set up an index. So when I said go find user ID 100, it couldn't do that very efficiently. It actually had to do a full table scan because MongoDB doesn't automatically index things for you, kind of like Cassandra does. You have to do that by hand. So to drive that point home, let's do an explain plan on that query to get more insight into what was going on. So to do that, I can do db.users.explain.find user ID colon 100 like that. And that will do an explain on the query, telling you what it will do under the hood to actually execute the command find on the expression user ID 100. And you can see here, all it's doing is a scan on the winning plan, looking for user ID 100 going forward. So it's going to just start at the beginning of the entire database and chug through it forward, one document at a time until it stumbles across user ID 100. So obviously not the most efficient way of doing a lookup. So to fix that, let's make an index. So to do that, we can say db.users.createIndex user ID colon 1. And what this means is I want to create an index on the user ID field, and the 1 just means it's ascending. So that's going to give you back a sort order that's in ascending order if you want to optimize sorts as well. And once it has this index on the user ID field, it can much more quickly look up where to find a given document for that user ID. Okay, so that came back okay. Let's do that same explain plan again. And we can see here that it's doing something a little bit more intricate here for the winning plan. So we're going to do, instead of a scan, an index scan, looking for user ID 1. And that's going to be a lot more efficient, obviously. Let's make sure it actually works. And came right back. So that's an example of setting up an index in MongoDB. And remember, MongoDB does not set up an index for you like Cassandra does on your primary key. You have to do it by hand. And if you forget to do it, your database is going to be horribly inefficient when you do lookups. Okay? So let's play around with MongoDB's built-in aggregation functions just to see kind of some of the more powerful things you can do with MongoDB. Remember, kind of the value proposition of MongoDB is that you can do more complex operations. Sometimes you can do things that you would normally need Hadoop to do within MongoDB itself. So as a fun example, let's aggregate all of the users by occupation and figure out the average age for each occupation. So what's the average age of a student? What's the average age of an executive? And so on and so forth. So to do that, we can use something like this, db.users.aggregate. And this function is going to take an array of commands. So I'm going to do an open bracket for that. Now, the Mongo shell can automatically figure out if a statement is complete or not, and if it's not, it will just automatically continue on to a new line. So if you want to keep things a little bit more neat, you can do it that way. So the expression we're going to pass in for the first group is $group, and in Mongo, things that start with a $sign means that this has some sort of special meaning to MongoDB. So a group is a command that MongoDB recognizes, and that will take in an expression like this, _ID colon, indicating the ID of the field basically that we want to group each document, group all the documents by, occupation, colon, occupation. So we're saying we want to group on the occupation field, and we're going to name the resulting field that we get back occupation. And we also want to create another field called average age in the results that will be based on this expression using Mongo's AVG function for averaging. And that itself will take a parameter of $age, meaning that we want to average the age field from each document for each occupation. Okay, so let's close that off. Close bracket, close parenthesis. And there you have it. Pretty darn quick. So it turns out that the average entertainment professional is 29 years old in our data set. The average programmer is 33. The average educator is 44. Average scientist 35. Let's see, where's students? Students 22. So this data kind of makes sense. And the average retired person is 63. So, these results seem to pass the sniff test. They make sense. It actually worked. Very cool. What are some other things we can do? Let's just play around with this data some more. So how many users are in our database? We can do db.users.count. 943 users that we have in this little data set here. So not a huge sample, but still enough to get some interesting data. Let's take a look at the actual collections that are in our database. So we should just see our users collection that we created, sure enough. And just to clean up our mess, now that we're done, let's drop that table. db.users.drop, we'll get rid of it. And now if I do a db.collectioninfos again, there's nothing in this table at all. So we cleaned up our mess. Very cool. Let's type an exit to get out of the shell. And finally, just to make sure that we clean things up properly, because Mongo will not be happy if you shut things down non-gracefully. Let's go back to our Services tab here for MongoDB. And stop that guy. All right, so if that stops successfully, we should be able to safely quit out of everything. Exit out of the shell here, and we can actually shut down our virtual image here as well, our virtual machine. Cool, so that's MongoDB. Had some fun with it. So that's MongoDB. If you have an existing installation of MongoDB in your organization, hopefully this will help you understand how it works and what's going on under the hood, and how you can integrate it with something like Apache Spark to actually conduct analytics on top of your data that's stored in MongoDB, and potentially export data to MongoDB to be served to your front-end web applications. So we've talked about a variety of different NoSQL database technologies out there. How do you choose between them? We'll talk about that next.